The Aerospike cross-data center replication feature, or XDR, asynchronously replicates cluster data between data centers and is commonly used for disaster recovery, regulatory data locality requirements, content delivery networks, fast local writes, and greater site autonomy. Each data center defines its replication configuration and the granularity of the data shipped from one to another. A data center can ship one or multiple namespaces, all or specific sets, or all or a subset of bins, depending on the replication needs. Using XDR filter expressions, introduced in Aerospike version 5.3, enables you to dynamically define the records shipped between data centers. This ensures your data is only where it needs to be, and helps with regulatory compliance, while also lowering network traffic, storage and processing needs, and the cost of moving data. Aerospike automatically tracks a record's last update time based on write transactions. XDR tracks a record's last ship time, the last time records were successfully shipped, which is persisted by partition. These two items together allow the system to identify if a record should be shipped by comparing the last update time with the last ship time. If the last update is greater than the last ship, the record is shipped based on the XDR configuration. These replication writes are tracked in the event they are needed to recover from node failure. Once the process is complete, the last ship time is updated. Aerospike supports a variety of configurable topologies. To illustrate the first two, we'll use an example with two data centers, Data Center A and Data Center B. In an active-passive topology, a client only writes to a single data center, for this scenario, Data Center A, while the other, Data Center B, works as a standby used for reads. Client writes are shipped from A to B, but B will not ship client writes back to A. This topology is often used to balance performance on the main data center. In a mesh, or active-active topology, clients write to both data centers A and B. When writes happen in one data center, they're shipped to the other. This would typically be used when dealing with users spread across a wide geographical area. This topology would generally not be a suitable option when the same record could be written to both data centers simultaneously. However, with Aerospike version 5.4, bin convergence was introduced to help with these potential write conflicts. Bin convergence ensures that data is eventually the same across data centers once replication is finished. In a star topology, one data center simultaneously replicates to multiple data centers. This is commonly used in situations where data is centrally written and then replicated to other locations for local reads. Linear chain topology works as a daisy chain, where one data center ships to another, which then ships to another, which ships to another, and so on until the last data center, which will not ship to any others, replicating data linearly across the chain. Finally, Aerospike supports many hybrid combinations of these topologies as well. XDR is able to handle local node failure by providing the same redundancy a single Aerospike cluster offers. When communications fail between data centers, the time the link went down is recorded and shipping is suspended to the affected data center. Once the connection is back up, shipping resumes with the new writes and any writes that took place during the interruption. XDR is also able to seamlessly handle situations where a combination of both local node and remote link failures happen at the same time.